Okay, so in today's lesson, we are talking about section 10.2. We're still talking about quadratic functions. We're talking about graphing a different type of quadratic functions. So last section, we just talked about graphing functions that didn't have this middle term here. They just had the ax squared term and then the plus c. So remember, the a tells you whether it's going to open up or open down. It's also going to tell you how wide it's going to open. So remember, a fraction means it's going to open really wide, and a whole number that's greater than 1 is going to open very narrow. And then the c, so this plus c, or in other cases a minus c, it would tell you whether it takes the parabola and moves it up on the graph or moves it down on the graph. Okay, so now we're talking about what happens when you have that middle term. How do we graph it? What do we do? That whole process. So that's what we're going to talk about today. So first and foremost, the first property that we're going to talk about is the graph of this quadratic function has the line of x equals negative b over 2a as its axis of symmetry. Okay? Once we use it, it'll make more sense. I want you to remember that an axis of symmetry is that line that goes through the vertex, right? It splits your parabola in half, so that way you have matching sides of your parabola. And again, we're going to talk about that more when we go through these examples. Before we actually get started, I want you to flip over your paper, and we're going to write down the steps. So these are the steps we're going to follow. Okay, and I will try and keep it color-coded as best as possible. But our steps, clear up. It should clear. There we go. Okay, so step 1. Step 1 is find the equation. Find the equation of the axis of symmetry. I'm going to abbreviate SIM. And the coordinate of the vertex. Okay, so that means we're going to use our new equation of x equals negative b over 2a. And then you'll kind of see how we're going to take what we find and we're going to plug it back in to find our y value. And again, I'm going to walk through that over on the other side. So then step 2 is going to be find 2 other points on the graph. Okay, and again, I'm going to walk you through that, so it's okay if these aren't fully making sense right now. Step 3, reflect across axis of symmetry. To get 2 more points. Okay, so I want you to keep these handy. I want you to kind of refer back to these as we go through, okay? And again, I am going to try and color code as much as I possibly can. So let's talk about this first example. We want to graph y equals negative 3x squared plus 6x plus 5. So step 1, we want to find the equation of the axis of symmetry and find the coordinate of the vertex. So we're going to use our new formula up here to find the equation for the axis of symmetry. So we have, so I'm going to write like a little 1 over here. We have x equals negative b over 2a. Okay, so now we want to directly substitute into this formula. Use this general form up top to help you identify a, b, and c. Okay, so when it says negative b over 2a, b and a are in these positions. Okay, so b is going to be 6. So when we substitute, we're going to have negative, I'm going to put it in parentheses because we always use parentheses when we substitute. So we have negative 6 over 2 times a. Well, a is negative 3. So we substitute in like that. Then we want to simplify, so we get negative 6 over 2 times negative 3 is negative 6, so we get 1. Okay? So the first part is our axis of symmetry. Equation is x equals 1. Okay? So now that we have x equals 1, I want to find the coordinate of my vertex. And remember, your axis of symmetry, I'm actually going to go ahead and graph this, and maybe that'll help with the explanation that I'm about to explain. So when we graph x equals 1, it's your axis of symmetry. Remember, it's not actually part of the graph, so it's going to be a dashed line. So go over to x equals 1, and we're going to draw a vertical dashed line here. Okay, so that's kind of be where like the middle of your parabola is. So you want both sides to be the exact same. Now, remember about your axis of symmetry, your vertex has to be on this line. Okay, that's the rule of thumb with graphing quadratics. So if it has to be on this line, that means the x coordinate in your vertex is going to be 1. So in order to find the other half of the coordinate, we have to take x equals 1, plug it into the equation, and solve for y. So here we go. This is what it's going to look like. We're going to have y equals negative 3x squared plus 6x plus 5. And I want to take 1 and I'm going to substitute it in for x. So we get y equals negative 3 parentheses 1 squared plus 6 times 1, so I'll put 1 in parentheses, plus 5. We're going to get y equals, well, we have 1 squared, which is 1 times negative 3, so we get negative 3 plus 6 times 1 is 6 plus 5. So negative 3 plus 6 is 3 plus 5 is 8. So y equals 8, x equals 1. That gives us a coordinate of 1, 8. Okay, so that's step 1. Find your axis symmetry equation and find your vertex coordinate. Okay, so we found the coordinate by plugging in 1 for x, solving for y. We got 8. Okay, so now I'm going to go down to my graph. I'm going to go down. I'm going to graph my vertex. So I have 1, 8. So 1 and then up 8. 1, 2, 3, 4, 8. Put a point. And that's my vertex. Okay. So now step 2. Find 2 other points on the graph. As a general rule of thumb, you typically pick the points that are directly next to the axis of symmetry. So in this case, we're going to pick something on the y-axis. So that means x equals 0. So x equals 0. And then let's go one more right next to that. So x equals negative 1 as well. So when x equals 0, plug it in. You're going to get y, negative 3, 0 squared, plus 6 times 0 plus 5. So you get y equals 5. I'm going to write my coordinate as 0, 5. And then while I'm working with that, I'm just going to go ahead and plug in my negative 1 right away. Y equals negative 3 parentheses negative 1 squared plus 6 parentheses negative 1 plus 5. So we're going to get negative 1 squared is 1 times negative 3 is negative 3. Negative 3 plus negative 6 is negative 9 plus 5 is negative 4. So I get a coordinate of negative 1, negative 4. So I'm going to box these so they stand out. And then I want to go ahead and graph these. Okay, so I'm going to go ahead and graph 0, 5. 1, 4, 5. And then negative 1, negative 4. 2, 3, 4. Okay. so again, kind of to reiterate that one, here's my vertex, okay? I wanted to pick, now, if you wanted to pick 2 points on this side of the line, that's perfectly fine. You're just going to have different numbers here and have different coordinates. Again, no big deal. Your graph will end up being the same, okay? So I picked the x value that is directly to the left and then directly to the left again. So I picked 0 and -1 because they're directly next to my axis of symmetry. And then I found that y equals 5 and y equals -4. So then I plotted my points when I plugged in my x values to my equation. Okay, now step 3. Step 3 says reflect across the axis of symmetry to get 2 more points. Okay, so let's talk about this for a second. If this is our axis of symmetry, right? So the axis of symmetry means that this side of my parabola needs to be identical to this side of my parabola. So I could take x equals 2 and x equals 3 and plug them in and find what their y values are. But that sounds kind of like a lot of work, and I don't really feel like doing that much work. So knowing that the axis of symmetry means that it reflects or it's symmetric on both sides, meaning this side is going to be the same thing as this side. If I go 1 point over from my axis of symmetry over here, it should match the same height as 1 point over on that side. So that's what it means by reflected on the other side. We know that if we go 1 point this way, it's going to have the same height as if we go 1 point that way. So then if we go 2 points this way, it has a height of -4. So if I go 2 points this way, this guy should have a height of -4. And if you want to double check the math and you want to plug in those points just to make sure that it works, you will find that it does work and you will get 5 and -4. Now you can go ahead and draw your parabola. Okay, so that's it. That's the entire process. So let's walk through it again. Let's start off with number 1. We want to find the axis of symmetry equation and find the vertex coordinate. So x equals -b over 2a, negative parentheses, -6. Notice how I have the double negative there, over 2a. What's this invisible number in front of x squared? What is that number that that's always there, but we don't always see it? It's going to be 1. So negative gives me a positive. Multiplying, you get 2, so my answer is going to be 3. So my axis of symmetry is x equals 3. Okay, now I'm going to take that 3, plug it into my original equation, right, and then find what my y value is. So we've got y equals x squared minus 6x plus 9. Plug in x equals 3. So 3 squared minus 6 parentheses 3 plus 9. And we are going to get 9 minus 18 plus 9. So 9 minus 18 is -9. -9 plus 9 is 0. So my coordinate's going to be 3, 0. I'm going to go ahead and draw 3, 0. 1, 2, 3, 0. I'm also going to go ahead and put in my axis of symmetry. So vertical line, dash line, at x equals 3. Okay. Number 2, find 2 points. I typically always work to the left. It really doesn't matter. You'll find that it's easier to work with smaller numbers than it is bigger numbers. So because we're starting at x equals 3, if you want to work with 4 and 5, go for it. But I don't really feel like squaring them and then multiplying them by 6. And then it's easier for me to work with smaller numbers, but you do you. So I'm going to go ahead and pick x equals 2 and x equals 1. So x equals 2, y equals 2 squared minus 6 times 2 plus 9. So I get y equals 4 minus 12 plus 9, which equals 4 minus 12 is -8. -8 plus 9 is 1. So my coordinate point is going to be 2, 1. X equals 1, plug it in. 1 squared is 1 minus 6 times 1, which is 6, plus 9. And that's going to give me negative 5 plus 9, which is 4. So I get 1, comma 4. So I'm going to go ahead and graph these 2 points. So 2, comma 1, and 1, comma 4. 1, 2, 3, 4. Okay. Number 3 is reflect. So if I went 1 point this way and 1 point that way, same height. 2 points that way, 2 points this way, same height. That's going to be my parabola. Draw it. Nice and neat, and you're done. Okay, so as long as you follow those 3 steps, it will give you a nice, neat parabola.